Hello, today we are going to cover topic 1, Introduction to Earth Systems, lesson 1, Matter and Energy in Earth Systems. And that'll be pages 4 to 11 in your textbook. So the first thing we're going to do is the connect it, which will be on page 4. And it tells us to draw a line on the photo to indicate where the surface of the lake was in the past. So you need to go ahead and do that now. And your line should look something like that, where you can see the difference between the brownish colored rock to the gray rock, where the water was and has receded. So what happened to the water in this lake, and why do you think this happened? And your answer should say the water has receded, like I said. The water is drying up because the area is experiencing a drought. All right, the Earth system. So a system is a group of parts that work together as a whole. The universe is the biggest system of all. Earth is a system and has smaller systems within it. This system involves the flow of matter and energy through different components. Academic vocabulary. So system is one of our academic vocabulary words. Much of science involves identifying components of different systems. You need to list 2 systems you hear about in everyday life. What are their components? So you should go ahead and do that under academic vocabulary in your textbook. The water and rock cycle. So for the water cycle, we have evaporation, condensation, and precipitation. So evaporation is the process by which molecules at the surface of a liquid absorb enough energy to change to a gas. Condensation is the change in state from a gas to a liquid. Molecules slow down and they lose heat. Precipitation is any form of water that falls from clouds and reaches Earth's surface as rain, snow, sleet, or hail. The rock cycle. So we have 3 different kinds of rocks: sedimentary, igneous, and metamorphic. So sedimentary rock is a type of rock that forms when particles from other rocks or the remains of plants and animals are pressed and cemented together. Sediment is small, solid pieces of material from rocks or the remains of organisms. Igneous rock is a type of rock that forms from the cooling of molten rock at or below the surface. Metamorphic rock is a type of rock that forms from an existing rock that is changed by heat, pressure, or chemical reactions. So now in your textbook, there's a reading check, and it says, how are the rock and water cycles similar and how are they different? So both cycles involve the flow of matter and energy through different components. The water cycle describes the movement and changes that water undergoes. The rock cycle follows the changes and movements of rock. So moving on from water and rock cycles, we're going to talk about Earth spheres. So we have the atmosphere, the geosphere, the hydrosphere, the cryosphere, and the biosphere. All of these are vocab words, so if it's in yellow highlighted, that means it's vocab. So atmosphere is the relatively thin envelope of gas that forms Earth's outermost layer. It contains air and dust particles, and it also contains the weather. The geosphere is most of Earth's mass, and it is in the form of rock and metal. So geosphere contains most of Earth's mass with rock and metal. So it includes the inner core, outer core, mantle, and crust. The hydrosphere is all of Earth's water. Then within the hydrosphere, we have the cryosphere. And the cryosphere is the frozen component of the hydrosphere. So that's specifically the ice on the land and sea. So biosphere then is the part of Earth that contains all living organisms. Going into more detail about Earth's spheres. So Earth has 4 major spheres that cycle matter and energy and shape Earth's surface. We're going to label each box with the correct sphere name, then list at least 2 spheres that show an interaction within the photo. So over here to the left, with this picture of the clouds and the birds, we have the atmosphere, and it is Earth's outermost layer which receives energy in the form of sunlight that passes through it and from heat that rises from Earth's surface, including the ocean. Heat rising from Earth's surface creates wind, which distributes heat as well as water through the atmosphere. So talking about the photo, we see the biosphere, birds, hydrosphere, clouds, and atmosphere are all interacting in this photo. For the second picture with the volcano, Earth's rock and metal contain an enormous amount of energy. Exposed rock absorbs sunlight and radiates heat into the atmosphere. In some locations, energy and new material make up the rocky outer layer of the geosphere in the form of lava. Major eruptions can affect the atmosphere, which in turn affect the hydrosphere and biosphere. So here, the sphere we're talking about is the geosphere. And in our picture, we see the biosphere, trees, geosphere, volcano, and atmosphere are interacting in the photo. All right, continuing on here with the polar bear, we have liquid water, which absorbs energy from sunlight, moderates the climate. When the atmosphere is cold, heat from the ocean can keep the temperature above freezing. When the atmosphere is warm, the ocean absorbs some heat, making coastal communities cooler. Snow and ice reflect sunlight, which otherwise would be absorbed by soil, water, trees, and rock. Without water in all of its forms, Earth would have extreme changes in temperature. So the hydrosphere that this is talking about is, of course, or the sphere that this is talking about is, of course, the hydrosphere, as I just gave it away. And our answer is the biosphere with the polar bear, and the hydrosphere, which is ice and water, are interacting in this photo. Our last picture of our tree frog here. Life has been found in virtually every part of Earth, from deep below the continental ice shelf of Antarctica to high up in the Himalayan mountains. So because we're talking about life, that's the biosphere. Bio means life. And the biosphere or frog and atmosphere are interacting in this photo. All right, continuing on, energy flow. So energy, which is a vocab word, it is the ability to do work. The constant flow or cycling of matter through the Earth system requires energy. The two main sources of energy in our system, the system of Earth, is the sun and heat from Earth's interior. Time for a reading check. So which part of each sphere do you interact with in your daily life? Give one example of each of the main spheres. So I'm going to give you an example or a sample. You can write anything that you would like, how it's related. So an example would be, I breathe the air from the atmosphere. I walk on rock from the geosphere, drink water from the hydrosphere, and eat food from the biosphere. System feedback. So feedback is the system returns or feeds back information about itself, and that information results in change. Positive feedback reinforces, speeds up, or enhances the process that's already underway. Negative feedback causes a process to slow down or go in reverse. What would be examples of each? So, positive feedback would be glaciers melting. Less glacial ice results in less sunlight being reflected, so waters warm faster, which causes glaciers to melt faster. And then an example of negative feedback, not necessarily in Earth or something, but something related to the biosphere, would be like brumation or hibernation in animals. So when the temperature gets lower, it causes the animal's body to slow down so that they go into their hibernation state. So hibernation would be what bears do. Brumation is reptiles and amphibians. Just fun facts there. So feedback is an academic vocabulary word. So feedback involves a loop in which a signal or action triggers another signal or action. This can happen when a microphone picks up sound from a speaker that is amplifying the microphone signal. The equipment passes the signal back and forth, and it becomes louder and harsher. What is one form of feedback that you encounter in your life? So, you should answer that in the academic vocabulary section of your textbook. Then also we need to stop and do the reading check. Name a reason why melting glaciers are considered positive feedback. So as a glacier melts, the surrounding land and air get warmer, and that causes the glacier to melt even faster. All right, so now we're going to do the model it on page 8. So sea ice and climate. Liquid and solid water are important factors in controlling climate. A large body of water can absorb energy from the sun, while snow or ice reflects solar energy back into space. In recent years, the amount of sea ice, frozen water in the Arctic Circle, has been dwindling because the air and water have been warmer than usual. As more of the Arctic Ocean is exposed due to loss of ice, it absorbs more sunlight and gets warmer. This makes it less likely for sea ice to form even when the air is well below freezing. So on the image provided, draw and label a cycle diagram for the feedback that is occurring in the Arctic among ice, liquid seawater, atmosphere, and solar energy. So first we're going to draw our cycle here. For mine, I just did 2 arrows, but you should probably have 3. It was just difficult to get them on the PowerPoint here. Then labeling. As the ice melts, more heat enters the atmosphere, making it warmer. Then warmer temps keep the ice from forming. And finally, the sun warms the exposed water, melting the ice. All right, so this is our math toolbox. Arctic sea ice. So historically in the Arctic, winter brought virtually endless nights and frigid air that could freeze seawater. In summer, much of the sea ice melted as the days grew longer and temperatures rose. Today, more ice is melting than ever before. The total area of Arctic sea ice has changed in recent years as the globe has warmed. The graph shows the amount of sea ice found in the Arctic Ocean from the following years: 1986, 1996, 2006, and 2016. What is the trend in the data? So less sea ice has been forming in the Arctic, so we can see how it decreases with each 10-year period. Then, what was the lowest extent of sea ice in the data, and when did it occur? So that was about 4 million square kilometers in August of 2016. What will happen to the extent of sea ice in the Arctic if temperatures continue to rise? Incorporate what you know about feedback into your prediction. So the extent of sea ice will continue to decline. The trend in the data shows less ice each year. The warmer it gets, the less ice can form, which means the sea absorbs more light and gets warmer itself. Interacting spheres. So in some cases, one sphere can affect another, which in turn can affect another. How is it possible that Greenland is actually getting taller with it losing ice? Can land actually rise and lower like an object that floats in water? So buoyancy of land masses. A land mass can rise and sit higher on Earth's surface if it sheds a lot of mass, just like a boat floating on water. So in this case, Greenland is losing ice, and the ice is what holds its mass. So if it's losing ice and losing mass, it is going to be able to sit up taller. It's going to float more, basically, is the philosophy there. All right, that comes to the end of lesson 1, which means it's time to do our lesson check. So here we're going to answer these questions. Number 1, what is the term for the part of the hydrosphere that is frozen? And that is the cryosphere. Now we're going to use the rock cycle diagram below to describe how energy is involved in the cycling of matter in the geosphere. So we're going to start with the green. Rock cools and hardens. Solid rock is broken into pieces. Pieces harden into another type of rock. Rock goes back into earth and melts. New rock emerges from inside earth. So hot rock is made. Heat leaves it, so it hardens. Eventually the rock gets melted down again when it goes back into earth. 3. Cause and effect. During the water cycle, water evaporates, rises into the atmosphere, and eventually falls back to Earth's surface as precipitation. What is the original source of energy that produces these changes? And the energy comes in the form of heat from the sun or from within Earth. 4. Give an example of the hydrosphere interacting with the geosphere. So water evaporates from the ocean and other bodies of water. It enters the atmosphere, then the water falls back to Earth. It may soak into the ground or cause erosion. 5. Give an example of how changes in the cryosphere affect the biosphere. So when there isn't much ice in the polar regions, penguins and polar bears have less habitat. And that finishes lesson 1.